Engineers spent millions trying to cool buildings without electricity. They failed. Then they looked at a termite mound. Problem solved. Nature's been engineering for 8 billion years. We've been doing it for maybe 300. Who do you think has better solutions? Let's start with those termites. In Zimbabwe, there's a building called Eastgate Center. It uses 90% less energy than normal buildings. Zero air conditioning. The secret? Termite technology. Termites in Africa build mounds that stay cool inside. Outside, it's 100 degrees. Inside, a perfect 87 degrees. How? They build a network of tunnels. Hot air rises through the center. Cool air gets pulled in from the base. It's a natural air conditioning system. The architect copied this exact design. He added vents and chimneys to the building. Air circulates naturally. The building breathes like a termite mound. It saves $5 million per year in energy costs. Not bad for copying bugs. Now let's talk about gecko feet. Geckos can walk up glass. They can hang from ceilings. They can stick to almost anything. For years, scientists thought it was suction, or maybe glue. They were wrong. Each gecko foot has millions of tiny hairs. Each hair is 100 times thinner than human hair. These hairs use something called van der Waals forces. It's molecular attraction between surfaces, billions of tiny contact points. Each one creates a weak bond. Together, they're incredibly strong. A gecko can support its entire body with one toe. Scientists copied this design. They created a tape that works the same way. It sticks to anything. It leaves no residue. You can use it thousands of times. NASA is testing it for space applications. Imagine repairing satellites with gecko tape. Japan had a problem. Their bullet trains were fast, but they were loud. When trains entered tunnels, they created sonic booms. Windows shattered in nearby homes. Engineers needed a solution. An engineer named Eiji Nakatsu loved birdwatching. He noticed how kingfishers dive. They go from air into water without a splash. Their beak shape cuts through both mediums perfectly. Nakatsu redesigned the train's nose. He copied the kingfisher's beak exactly. The result? The train became 10% faster. It used 15% less electricity, and the sonic boom disappeared. Passengers near the tracks don't even hear it coming. One bird solved a multi-million-dollar problem. Sharks are fast, really fast. But here's the weird part. Their skin isn't smooth. It's covered in tiny scales called denticles. Under a microscope, they look like tiny teeth. These denticles reduce drag by 8%. They channel water efficiently across the body. Swimmers noticed. Olympic swimsuits now copy this pattern. The suits reduced drag by 4%. That's enough to win gold medals. Records fell everywhere. But it doesn't stop at swimsuits. Airlines are testing it too. Paint infused with this pattern reduces fuel consumption. One airline saved 8 million gallons of fuel. That's $5 million per year, all from copying shark skin. Lotus flowers grow in muddy water, but their leaves stay perfectly clean. Water rolls right off them. So does dirt. Scientists studied this under microscopes. The leaf surface is covered in tiny bumps. These bumps are coated with waxy crystals. Water can't stick to them. It forms perfect spheres instead. As water rolls off, it picks up dirt particles. The leaf self-cleanse. Engineers copied this design. Now we have self-cleaning paint, self-cleaning windows, self-cleaning fabrics. The coating works exactly like lotus leaves. Rain washes away dirt automatically. No cleaning needed. Buildings stay clean for years. You're looking at nature's solution to maintenance costs. Spider silk is 5 times stronger than steel. By weight. It's also incredibly elastic. It can stretch 40% without breaking. Scientists have been trying to replicate it for decades. The problem? Spiders make silk at room temperature, using water and protein. Steel requires 2,700 degrees Fahrenheit, massive furnaces, huge energy costs. If we could make spider silk artificially, everything changes. Body armor could be lighter and stronger. Medical sutures could dissolve naturally. Bridge cables could last centuries. Companies are close to cracking this. One company genetically modified yeast to produce spider silk protein. Another uses bacteria. The artificial silk isn't perfect yet, but it's 90% as strong as natural silk. And we're making it without spiders. Nature's recipe, human production. Wind turbines have a problem. At low speeds, they stall. They need strong wind to work efficiently. Humpback whales have bumps on their fins. These bumps are called tubercles. They look inefficient, but they're not. The bumps create tiny vortices in water. These vortices increase lift by 8%. They reduce drag by 32%. Whales can turn sharper than any creature their size. Engineers added these bumps to wind turbine blades. The results shocked everyone. The turbines generated 20% more power. They worked at slower wind speeds. They were quieter. One wind farm with this design powers 100,000 homes extra. That's free energy from copying whale fins. Here's what all these examples tell us. Nature isn't just beautiful, it's functional. Every shape has a reason. Every structure solves a problem. Evolution tested designs for millions of years. Bad designs died out. Good designs survived. We're reverse engineering. 8 billion years of research and development. And it's free. The answers to our biggest challenges already exist. Climate change? Look at how ecosystems regulate temperature. Energy crisis? Study how plants capture sunlight. Water shortage? Learn from desert beetles that harvest fog. We don't need to reinvent the wheel. We need to look closer at nature's wheels. The next time you see a spider web, think about medical technology. When you see a bird dive, think about trains. When you watch waves crash, remember there's engineering happening. Nature isn't just our environment, it's our research lab, our solutions library, our inspiration. We just need to pay attention. If this changed how you see the world around you, you know what to do. More fascinating science coming soon.